Hello and welcome. I'm Bill Wake. We've got some background noise today, so bear with me if it's unbearable. We'll just turn down the volume, I guess. Can't do much on this end. All right, today we're looking at the Bitwise logical operators, so not and and or. We've gotten our way through most of the operators, actually all of them, as far as lexing, parsing, interpreting, but we ran into an error yesterday when we tried to test it. Okay, so let's take a look. We made this test. We did the interpreter test. Right, so we came up with this complicated expression and worked out the math with a little help from the system generating the right answer for us. And we've got this expression that represents that. Not, hey, good morning, Rick Lowe. Nice to see you back. We've got the expression, we can see the not -8, and then the or, and the and 5 and 4. So it's a representation of this, and this test passes. And notice what it does. It's got a little program that just has one line and prints that expression. And it should get the 7. Yeah, there we go. And I said, well, it's sure a lot of work to write a big old hairy tree like this when the whole point of the compiler or the interpreter is to let it do the work. So we switched over to the interpreter level tests and said, let's test that same program. Well, I changed the line number, but that's okay. Test that same thing, and we run this. Okay, and this test fails. So what does it get? It doesn't print anything. All right. Now, the way we tested our interpreter, this is kind of it's a reflection of kind of unit test versus end-to-end. So in our unit test here, I developed an expression that's exactly the expression I expect the parser produce, and the interpreter does that perfectly. Okay. So the question is is the parser producing this expression? And I'm going to cut forward because I peeked. I went in and looked to make sure that print calls expression, which is the top level expression, like op. And since we already do plus and minus and times and all that, we know it can do those. And it does expression. But notice this. It's checking is the print statement looking at an integer. Okay. Well, that was great when we started out because our expressions were so simple, they only consisted of integers. But now we can have a not in front, or a minus sign, or a parenthesis, or any of that stuff. So this is not adequate. Our print statement, we're only handling a subset of things. Now, I think the challenge is if you can just say print with no arguments, okay? But if you want a print argument, we had to deal with a case of 0 or 1. And really, the specification calls for 0 or more. And it also has these comma and semicolon operators that control the spacing. So this shortcut in the parser that was great when it was just integers, now it's not so great. Okay, now there are different ways we can handle this. One is if it's a print statement, if it's just a plain old print, no arguments, then whatever's after the print statement is either the next line or it's the end of the file. Okay, and let's make sure we have an end of file token at end. Yeah, so it's either going to be at end or line number, integer. That's a deeper problem then. Okay. We may have to keep track of our line starts a little better. Okay. But if it's an integer, let's see back here. If it is an integer, well, what we really need to do is look at our grammar. Okay. This integer is the start of our expression. So in that sense, it's like what's the possible first token of an expression? Well, it's the same as that of an or expression, which is an and expression, which is negation. Oh, it could be a not. Let me just put the comments here. It could be a not. Or it could be relational, so sub-expression, term, power, work our way down. It could be a minus. It could be a factor, it could be an int, a number, or a parenthesis. Int, number, or left parenthesis. Okay, and, well, our number already does, this is the lexer that does this parsing, excuse me. Well, there's two things going on now. I thought I had one error, now I got two. So I could check if I'm in one of these tokens, then I would know that I should do an expression because it's a starting point of one of those. And that's a legit thing. But I think I'm concerned that we've only been doing little tiny, like one-line programs. We haven't dealt with moving from line to line yet. So we're leaving another problem. So let me record the problem. All right. The problem is if we had a print, a program with plain print will use the line number of the next line, e.g. if I have 20 print 30 print 42. Okay, I expect that this will print 20 and then 42. Well, how would I say that? I expect it will, if you had the two lines, it would parse it that way because we don't have an end of line token, but maybe we need one. It's a future problem, but let's get through this one. All right. So if it's an integer, then we got those things. If it's at and, well, let's try this. Let's say if the integer, if token at and is not token. Okay. So I'm saying if the next token is not, can I not do? No. Okay. If the next token is not at end, and I'm sorry, I just got to write these the other way around. I realize the case statement thing wants the other way, but this is just too much what I say. Okay. If the current token is not the end of the file, then let's go ahead and try the expression. All right. And notice the other thing. This only allows one expression. We haven't dealt with multiple expressions. So print with strings, print with this. We need to handle print with multiple expressions. Okay, because 25 print 42 21 is legal. Okay. It implicitly puts a space between entries. All right. And this now I think will fix what we did. So because we only allowed integers, the not expression we had is rejected, and we just print, which print a new line. Okay. Let's go to interpreter. Print, do print. Okay. Notice it always appends a new line. If there are no values, this is empty, but it prints a new line. Okay. Let's run our test again now. We need basic tests. All right. Now I'm hoping this passes. Good. All right. So we fixed. Now it prints any expression. Okay. All right. That I think that means that fixes that. I called this the episode, but that's kind of like yeah, we're done in the first 12 minutes here. May 19. All right, so let's take this. Okay, program was playing back. What's the next thing to do is the real question. Well, I wanna go back to what we did. Review this a little bit. These have some duplication here, so I don't know how much I want to fight this one, but it it does build in these int conversions, and same thing on mine. Not. I think I'll let that be. If it grows any, we'll do something with it. But even if I inline that, I don't think it's too bad. Okay, so let's just look at this whole interpreter for a bit. This is, I don't know, it's one of the ways I deal with stuff. I'll get to a certain point and then just kind of go back and make sure everything just looks sensible. Okay, so I think they've got a pattern. Well, this one does the work, but they generally just defer to a method. I think that's fine. Then we got our operators. They're really two argument operators, and they all seem kind of reasonable. Bool to float, yeah. What is bool to float? Okay. Is that right? Equals. Oh yeah, we get a Boolean result from our equals operator, and in BASIC it's always a floating 1 or 0. Actually, the test, if you say if some expression, it tests for not equals 0, like C. Okay. So those operators look good. Now we're into the expressions, and that's okay. That's a little complicated. Again, it's kind of this point where if you have stuff that happens 3 times, it's usually better to kind of a rule of thumb, I guess. If it happens 3 times, you probably ought to pull it out and clean it up. This one, I've got 2 unary operators, and I don't think there are going to be any more. So I guess I'm going to let that be. Okay. Format, and that's the print. Okay. All right, I'm going to let that one go. The other one I was thinking about was the lexer. And okay, we did the work yesterday to run through reserved words. You know, I realize I was wondering if this default value, if we could give this as the default somehow, but I don't think we can. I was thinking that we ran across in some of the documentation yesterday, right? There's this kind of default operator, I could say. Well, there's no keyword it's going to be, so it's hard to say, but it's not quite right. Okay. Let's see. This it's a little clunky. This we split out because remark has to do its thing. Let's say, how do we handle new line? Return next. Okay, interesting. I think. Maybe we need to return that token explicitly. So maybe I will tackle this print thing. I don't know. We're not dealing with. Maybe we should handle print more. I don't know. I think at this point our expressions are complete in terms of the operators. We've done all the operators. We've not done variable names. Oops. And well, get it there. We haven't done array subscript names. Subscripts, we haven't done strings. There's a bunch of stuff in there. And let's see, back over to documentation. We haven't dealt with functions. Okay. And there's, I think the def, you can define your own functions named fna, fnb, and so on. Okay. Oh, I don't know. I'm kind of torn. I want to get through the expressions, and on the other hand, it'd be good to get some control structures going and like working from one line to the other, you know. So let's see. How do we parse a line? I know I'm bouncing around, aren't I? Okay, so the parse returns program. While token not equal add end lines dot append line. Okay, if it's a float. Sorry, if it's an integer. Okay, it should be an integer. Yeah, if it starts with an integer because that's the line number. Okay, and then we do a statement. Okay. And then a statement looks for remark. It looks for print. Okay, we only support the two statements now. Let's make this. Can we switch? This is, well, we'll do it when it grows. Okay. What I'm thinking is maybe we should be putting that new line token in, and looking for it. Okay, so a line should read a statement, and then it should consume the new line. Okay, so let's do that. This is sort of prep work to make that print statement thing work right. Okay. Make parser check for end of line, and what this is going to do is that's a requirement at the end of the line, right? We parse the whole expression. So what if you did this? If you said 25 print, well, print is not a good example, is it? Let's say this. A equals 4221. Okay. Well, let's do this. Hi. Okay. That is not legal basic. The funny thing is it squeezes spaces, so the 4221 won't give it a problem, but once, you know, there's no meaning to having two expressions in a row here. So we would expect that after the number, there should be an end of line. Okay. And this is an error. All right. Okay. So we're going to make the parser check for that end of line here after the statement. Each statement does its thing, pulls out what it wants, and then we should see an end of line at this point. Okay. So, let's see. So, sorry about the hammers. That's some work going on in the background. So I think it's like, can we do this without breaking anything? And I don't know. Yeah, we can. We can. Okay, so what we'll do is we'll add the token, and I'll just call it EOL, end of line. I have used this abbreviation for so long. I hope it's a standard one for the world. But this token, okay, so if I added it to the lexer first, the lexer would start spitting out EOL tokens after the end of each line. Well, no, it won't, because we just don't test anything that sophisticated yet. We parse it. Yeah. Okay. I think we can. We've added the token. That's fine. But let's see what test we can write. I don't know if we did a 2-line test yet. Is the thing. Okay. Unknown statement. Print statement. Print statement. Okay. Let's do a multi-line program before we get into the expressions. Okay. Let the program equal. I think we can do this. Well, maybe we can do our little exam. Maybe we are working on this thing. 10 print, 20 print, 42. Okay. That should be a legally parsed thing, but I think what's going to happen is our print parser is going to consume the line number, and then when the line parser comes back in, there's no line number, and we'll get this error. That's my prediction. All right, so let's do this stuff. Okay, what we'd like to see is line 10, print nothing. Let me duplicate this. Okay, so line 10, print nothing. Line 20, print number 42, and let's get the brackets and stuff right here. Is that a comma there? Line 10, print. That's the line. That's the line. Okay. Yeah, so we expect these two to come out, and my prediction is we will hit no line number on the second one. Yay. Oh, maybe. Line 10, print number 20. Okay, yeah. It did not throw an error. That's a little puzzling. I would have thought it would come here. But okay, that's enough. All right. So let's do I want to set that aside? Maybe I do. Let's set this test aside, and let's go back and do lexer tests. I guess that'll. We've already got kind of a boundary there. All right. So remark and let's test an end of line. Okay, and that should fail. It should get an end, I think. Yeah, so we were ignoring them before, and so if you take out the new line, then you just have ended program. All right, so lexer. And this had something I didn't like before. Notice what it does. It calls next. So new lines it was a little bit recursive. Well, sorry, it was recursive. Each new line in a row would cause this to happen. But in reality, you don't have much of that. It would only go once, but I'm happier without it. Okay. We skipped the token, and now instead of returning whatever the following token was, we're going to return the EOL token. Okay. And that should pass. Oh, so much for that theory. EOL is not equal to add end. What's the deal? Okay, if you see a new line, bump past it and return it. Are we getting there? All right, let's run this. Oh, am I looking at the wrong test? I am. Oh, interesting. Okay, so oh, we need to stop here then. This test is failing. Okay. Our test with the end of line passed, but the end one failed. Okay, so we're here. Let's print index is 0 and count is 1. How is that possible? That should be an empty string. The check token takes lexer of program. Okay. Lexer. There's the init. Takes our string. Oh, replaces empty, adds a new line. That's justified in a way because the last line should have a new line no matter what. But now, before we skipped it, now we don't. It maybe should have, I guess that's not correct now. I mean, I guess this program, this should return new line. Because I want to say every line is symmetric. They all have new lines, whether they do or not, whether I'm on a Mac or I'm on a PC or whatever. Okay, let's make a separate test. And we can, okay, well, token 1. And then we'll do the same thing. So we're not resetting anything. Okay, so this one we expect a new line. And then this one we expect an add end. And it's unfortunately harder to read as tests go. But okay, we'll say lex an empty file. You should see an end of line and an add end. Okay, and I think this will pass. Continue. I'll run again, I guess. Oops. How about we run tests? And remember, we commented out the parser test, so. Oh, index out of range. Lines has nothing. Which test is this? 20 print. Why does that have nothing? Did anything else run? 10 RAM. Okay, so the difference now is, I think our lexer, let's make sure. Okay, our lexer returns the end of line token and it returns the at end token. The parser, I think our parser will have to update now. So let's get back to our parser test. Parser test. Okay, let's check this one. All right. I'm just going to run, well, I'm going to run this file because it hasn't woken up to the fact that there's another test in here. Okay, so test print fails. Where's our multi-line? Okay. Program empty is not equal to that. Okay, so it failed to parse. I'm a little, I thought something would throw an exception on that, but okay, let's see what we got. Okay, so program, while we're not at end, it catches each line. Okay, the line, it looks for an integer start. If it doesn't see it, it's an error. It finds the int. Okay, parse dot line. Okay, we try a statement, but now we want to make sure. And I don't know if we have a check token. We don't. Let's say if token, well, which way I want to say it? If it equals .eol, then we want to do a next token. Okay, I think that's as far as we got. Okay, and so we get the line number, we get the statement, we make sure there's an EOL, and then we consume it. And so the next line that starts should have the right number. Okay, so let's try this one again. So, okay, what do I know? Program blank. And yet others passed. Okay. I'm truly puzzled. All right. Well, let's break here and see what's going on. Multi-line. Okay. We expect that to be good. We'll step over. Okay. All this was there before, so I expect. Where am I? How am I here? Am I throwing? Catch. Error messages append. Oh, where do my error messages? Oh yeah, the parser has a list of error messages. Okay. But statement failed to parse. Okay, let's run it again. so we're going to step in statement. Well, let's see what the token situation is here. Okay, so print token is a print. Okay, that's good. We've already consumed the line number. We should go in statement. We'll step in. Here's statement. Okay. Over. It should equal print. Yes. We'll step in. Print statement. Okay. We're skipping past. Ooh. Haha. Yeah, we were so clever. Okay. Right. So token here is this new token, right? End of line. Okay. Let's fix that one. Print statement. Okay. So if you're here, if it's not at end, well, it's end of line. That's a problem. This only happens. Well, okay. Now it should be EOL. Okay. We always have an EOL now. So if the token is not EOL, then we're not ending our line. We should print this, gather this value and then print it. If it is end of line, then there's no values gathered and we have an empty print. We had created it with an empty list, so it's okay. Wowzers. And I guess because we always have an EOL now, everybody that wasn't aware of that's gonna have a problem. All right. And okay, let's run this again. Parser Test. There could still be an issue around RAM, but let's get through this first. Continue. Good. Run all these tests. We still have a lexer issue. Okay. All right. Well, we're due for a break, so let's take a break, and then we'll figure out what's going on here. And really, it's something about this new line token. It's not being accounted for in the lexer, probably. Okay, yeah, we're not skipping. We skipped the remark. I think maybe the remark should consume the new line as well. So we'll take a break, 3 minutes, and come back and fix that, and then I think we're ready to move on. All right, welcome back. Okay, so I think we are to the point with this test. What we're seeing is you're checking that there's a line number. Let's break that a little bit more. There's a line number followed by a remark token, followed by a line number, followed by a remark, okay, followed by an end. And what we're seeing is we get our EOLs. And the question to me is, does the remark statement, how does it handle the end of lines? Okay. So I think what should happen, let's see, do I want to switch this? Well, I guess what I'm saying is the statement should, again, I'm sorry about the value. The statement, it should consume the new line as well. Okay. And in our case, we can either let the remark do that, or we can check after each statement that it's at the end. And that sounds better to me. So I'm going to take a little longer path, which is to switch on the token. Okay, so case.remark, we're going to do this. So this is turn switch statement into, or turn if statements into switch statement. Case, let's put this here. Dot print. Print. And we'll do this. This. and the other is the default. All right. Now, yeah, I think that's going to be a better structure. The test should fail the same two tests. Test 2 remarks and print a number. Everything else should be green. I didn't fix anything. I just refactored while red. Okay, so yeah, same two tests. All right. Now, I'm going to say, I think certainly the statement should consume the token. Okay. We could make it return hold a result. So let's say var result of parse. Okay. And I think I can do this. Return result and result equals okay. Yeah, so now instead of doing the whole statement, we're just gonna we're parsing it, and then we're down here. Okay, and at this point the statement should have it should have a new line there, an end of line character, because every statement should end with end of line. Okay, so let's check for that. If token no, well, if it equals end of line, then we just do next token and consume the end of line. Otherwise, throw parse error. I guess this is going to be extra characters at end of line. Okay, which doesn't exist. Okay, and I'm jumping forward a bit here. Okay. Lost my statements. There we go. Okay, so I'm enforcing that you have an, well, actually, either way. This thing needs to do an X token too. Okay. So if it is an end of line, we're going to consume it. If it's not an end of line, we're going to consume it anyway, and go from there. Okay. Our error handling could be better. All right. Again, everything should pass except those two. And they're lexer tests. Actually, the tests do need to be modified. Okay. In reality now, we are going to return that new token. So let's assert that it's there. It must be an end of line. And this one's going to have it too. Okay, so let's make sure this test passes. Probably should have gotten these working and then do the other. And print a number. Integer print 42, end of line, that. Okay. It seems like I could do some improvement in those tests, doesn't it? Okay, there's only two. I guess we'll go there. All right, now this we've switched it around. I don't think we have. Well, we don't have a test for this for sure. Um, this, let's see, that would be a parser test. We got an unknown statement. That's probably a nearby place to put it. Oh, but this is not going to work, is it? Yeah, we can't test that yet. um, let's add that to the to do. The reason we can't is because it is legal to have extra expressions at the end. Oh, but I'm trying to think what you would do. It's going to try and parse expression if we let it, and if it was a bad expression, it would have wrong stuff. I mean, you can't say 25 print. Okay, maybe that can do it. But at any rate, we should still record it. Okay, that's that error. 40 print is an error. Okay. Yeah, this is I'm not so sure about the test here. Okay, it'll be something like this. Test print. Sorry. Print is error. Okay. So print. I did it again. Okay. Result equals parser.parse. I don't know what it will produce. The real thing is parser.errors messages. Let's assert true. We should have an error message dot contains something. Okay. Let's go find error messages. It's parse errors. Okay. So it should contain this. And I don't think we care what the program is. If there's an error, we're not going to let it go. Contains parent. Okay. And I'm running the test backwards, unfortunately. Okay. Well, we're not paying attention to the result. Assert true failed. Oh, do I hate that? Assert equals parser error messages. Let's try it this way. Excuse me one sec. All right. Let's see. So, if I could get my syntax right here, assert equal parser error messages should be the one message. Okay. Yes. Search true failed. Let's try equals. Okay. Now, expected number or left paren is not equal. Okay. I think we're back to this print statement. Let's see. Where's print? Okay. Yeah. So we said if it's not end of line, then do that. And print is not end of line. So, it really is. I mean, I listed them out before, but what this really should be is, if, well, let's do this. Let expression first equal. Okay, and this is the possible starting characters for an expression. So that includes, oh man, can I do that? Integer. Left number. Left paren. And not. Okay, he doesn't like it. Well, this is token. I think he's still not going to like it. Yeah, he's got to have an argument. Oh. I like these little enums that Swift provides, but without it seems hard to get to the characters that are legal. Okay, let's try a different way. Let's do a switch. Token case integer case number case left paren case not. Okay. I don't know if I'm getting my syntax quite right, but do I need it after each one? Maybe I'm supposed to comma these. I don't remember. Number with nothing. Okay, and then default. Okay, by default, I think we do nothing. Okay. Yes, well, I'm going to put a statement. Okay, now, this we don't need. I'll get there. Member number expects arguments of type float. I can't remember the syntax. I guess I can comma list these. Okay. So our print, we skip over the print itself. If it's a valid expression start, we parse the expression and then do the default break. Okay, let's see if we're more like it. I'm feeling like maybe I'm cutting too many corners on print, and I ought to just bite the bullet and get that thing working. Okay. Now, how am I liking our statement stuff? Okay. Align. Okay. I think I've got two places requiring it. So statement. It's kind of like who owns this? I'm like consuming too many. Yeah, maybe I'm overdoing it there. If a line should be line number, statement, and end of line. That seems right. Okay. If it's not an end of line after the statement. Okay, so the statement, maybe this is the wrong place for it. If it equals end of line, do next token. Well, we did it up there, so that's the wrong place. So let me pull this. I think, okay, if I pull this and delete it, I think something should fail. Let's make sure that's true. Okay, good. And then, so I need to put it in statement line. Okay, if it equals that, let's change this. If it equals into line next token, okay, that's true. If it does not equal into line, then it should get an error extra characters message. So that test should now pass. All right. Okay, let's check in. This is a good point. All right, so we handle end of line in lexer, and in parser check that each line ends properly. Okay. And then I want to clean up a little. Okay. So what's missing to me? Okay, yeah. This is clunky and ugly. Okay. What I want to say is, I think I want to say require.eol and then dot extra characters. Okay. So I want to embed this, extract this. So I'm pretty sure extract method is not going to do it. It might. It does. Okay, let's call it require. It doesn't know the arguments yet. That's okay. We'll push them back. Okay, so this is the expected is a token. So let's use that. Oops. If token is expected next token. And then the message, if it's not there, token. Error of parse error. Throw error. So I can do a literal token, but I can't. Oh, and a function. What's expected? Token and something goes to token. Okay. I'm going to cut my mic for the minute when they're doing the worst stuff. Okay, so I'm going to pull out that. I'm going to hold the token, pull out that next token. So both branches get through it. And now, if held token equals expected, do this. If it not expected, throw. I may not be any better off. Binary equal cannot be applied to token. And let's see the type of this. Token. Token. The reason I wanted this, let's go down to expression. Where's right parend? Yeah, we have that same kind of thing here. This is a try. I don't know if I messed myself up with that. It doesn't seem like it. Equals cannot be applied to token, and something goes to token. Now let's try this caselet thing. If caselet expected equals held token. If condition is always true. Huh. Wow. Yeah, make sure I'm still mic'd on. All right, I don't know how to do this then. Huh. This definitely is confusing. Why is that not allowed? Now it is. Okay, maybe the compiler was just catching up. Okay. All right, let's run all tests and make sure. Okay, good. I was a little worried there. All right. Now, what I can't do is I can't like check is it any integer, but I can check these right parens. Okay, so I'm going to find the throws. Well, let's find that right parent again. Actually, let's commit this. And require to check for token and report error if not found. Okay, and we'll look for right parend. Okay, if token is right parend. So this, I think, is the same as require right parend and this. Okay. Oops, try. Okay. And what I'm trying to do with this is bump up the readability. So now it's like you see a left parend, consume it, try the expression, require the right parend, and then return the expression. Okay. And let's find any throws. I'm not saying everyone's a candidate, but many are. Okay, that one won't work. That's okay. Error. Yeah, so in a way I'd like to be able to require the integer here. It could be like, would it be better if it didn't do the next token? And then you're just checking what you're looking at. That would say, and maybe it's expect instead of require. Where did it go? There it is. Okay. What if I take this out and put it back into the callers? I think next token. And where's our parens? Require right parent, consume it. Okay. And let's make sure that works. And maybe changing something, like I'm not 100% sure on our error handling if it's okay. I guess it's all right. And I'm gonna change the name to expect. Do I want to? Maybe it requires better. Yeah, I think it is. Okay. Um, make caller of require responsible for next token. And there may be a simplification too. Let's go back to require. Okay, I don't think this is adding anything. Let's see if the compiler's happy. Okay. No, I think that's better. If the token is not what's expected, then throw an error. Otherwise, you do what you do with it. Okay. That means... Okay, so let's... inline variable in require. That's a pure refactoring. Okay, now I'm going to look for other places to use that. All right, and the prime candidate is this one. If you don't start with a line number, the logic here is kind of inverted, right? You say if you have an integer, then do all this stuff. I would rather just at the front say require line number, require. Oh, but I can't. I don't think I can say require dot dot integer. Can I do that? I wouldn't let me. Pattern. I don't think I can leave it out. Oh, it's not going to work. Okay. I guess if yeah, if we don't get an integer, we're just going to have to do it down here. Okay. All right. Let's go back to to-do. I think we are checking for end of line. A long way to get there, but I think we're there. Is line number on the next line, e.g., okay, we did this too. Add EOL token. Add end line token to prevent program with plain print. We'll use line number the next line, e.g. that. Okay, I would say that's what we did. All right. We haven't dealt with variables. So this is expressions. We got variables, functions, and subscripts. We haven't dealt with any of those. I don't want to do subscripts until we get into there's a dim statement that creates arrays. So we'll wait for that. But variables, I mean, you could do them and say they default to 0 or something. I think that might even be what the true default is. It's certainly legal to reference one. Okay. Let's do variables. Okay, so okay. So part of the struggle is I'm dealing with like how much breadth versus depth. Okay, so right now we have arithmetic expressions and logical operators on numbers, any kind of number, floating or int, and we have a print statement and we have a remark statement. I would love to get going on something a little more. Well, I want to get going on control statements. Okay, so maybe this is the not the next thing. Maybe go to an if would be more interesting. Although if can't do anything, well, we can start, but it's not complete. Okay, so let's deal with GOTO because that's going to be a whole different setup, right? We haven't dealt with control at all, and I don't know. I've got to make a decision about the interpreter. Is it going line by line, or is it going a program at a time, doing the whole program. And so far we've parsed the whole program and all that stuff, but I think you could make a good case for just doing a line at a time, and then the GOTO will kind of take care of that. So let's add the GOTO and start making that happen. All right, now the keyword should be in our list. We did all these. Okay, so there's a GOTO keyword, and that's where we checked for letters right down here. Okay, so far we've only mentioned uppercase, but that's okay. If you say GOTO, we will find it and you will get the GOTO keyword. All right, and let's see. So that lexer, the work is done. Okay, so the parse, we don't have a GOTO statement in the parse yet, so let's add that. Case GOTO, and the line, I think, is going to be an int. Okay, because it's matching up to the line number here. And our program is going to do something with that. Okay. If I build, I get complaints because things don't handle every case. Okay. Switch must be exhaustive. Okay. So let's do GOTO. And is this a throws? It's only an interpret. Okay, let's just get the case statement in there with something. We'll just do this for now. Switch must be exhaustive. Okay. I think it is exhaustive now. All right. Nobody should be complaining because nobody looks for GOTO. Okay, now let's do our parser. What's the warning? Update to recommended settings. Okay, well, parse, where's line and statement. Okay, so remark next token, parse skip, parse print. Okay, let's do GOTO. Result equals try GOTO. Okay, and we don't have a GOTO method. Okay. Func GOTO throws returns parse. Yeah. Okay. So we got in here because. Okay, let's throw parse error dot. I just want some junk to get out of the way here. Unknown statement. Okay. All right. Back to tests. Let's find. Cannot find parse. Oh. Okay, so I'm just putting in a little bit of framework for it. I really could start with a test. I probably should. All right, multi-line before the expressions. Okay. Test GOTO. Okay. Parser equals. Okay, try parser dot. Well, we want statement, I think. Well, let's do statement. Result should be expression. Statement. Parse dot GOTO with 10. Okay. Let's move this about that expression. And maybe I should do the whole program. I don't know. Yeah, let's do that. This one's closer. No, don't need to try? Okay. Okay, so go to 10 should produce the program line 10, go to 10. Sounds plausible. Okay. Got an empty program. Okay. Let's go down to GOTO. Did I get? No. Okay. All right. GOTO. So we basically want to consume the GOTO token. Okay. And then we need to. Well, we're expecting a integer there. Okay. If case let dot integer of no, put the let inside. I think that's optional, but it makes more sense to me. Let line number equals token. Okay, so if we do find a legitimate token line number there, then we're going to return GOTO. And the line number, if you recall, or maybe you weren't here, but the line number actually holds, the token actually holds a float for an integer because everything turns into a float for basic. So we're going to have to turn it into an int. Okay. And okay. And we'll deal with an error case in a minute. All right, so that should pass now. Shows what I know. Okay. We eat the GOTO, we check for an integer. Let's stop in here and see what that token really is. Could it be a float? No, it's an integer. Value 10. Okay. Step over. think that should be return GOTO of int line number. Okay. Well, let's look at results. Nil.
Not that you're gonna have anything to hold on to,
I don't know what's going. We return. Token. Okay. So program did not come back. Let's do that again. Okay, so we got tokens what we expect. It's the integer token. We'll step over. Okay, and we're going to return GOTO with int line number. Okay. Out. Okay, statement parse equals try statement. Let's look at that thing. Interesting. Okay, we'll step over. Here's GOTO line 10. Oh. Somebody didn't consume a token. Try GOTO. Okay, yeah. So we saw that the number, we ate the GOTO token, but we didn't eat the number token. And we've already saved the value, so it's okay. All right, this should just pass. They all should just pass. Okay, so we're parse the GOTOs. Okay. Yeah, so that's pretty good. The problem we have. Okay, well, let's deal with the error message. Okay, so where's it go to? We have not been checking messages, and that probably is something we should do. No, probably about it, of course. Test go to with error. Throws. Okay. So what's, well, if it said go to 20, I wouldn't have a problem. Let's say with missing target. Okay, so if we, okay, and I gotta get some parameterized stuff in here. Oh, okay, so let's just say no target. Okay, then we should get an error. XCTAQ parser dot messages should be parse error dot, and I think it's really like missing target of GOTO or something like that. Missing target. That's probably okay, which doesn't exist. Okay, let's copy this, go over here. Okay, so case missing target, and our test should fail because we throw a different error. Unknown statement. Okay, so this should be missing target. Okay. If we don't see an integer next, then yeah, there's a missing target. Okay. Alrighty. What else can go wrong? Well, you could have extra junk. If you had something that wasn't um, an integer, same thing. So I don't think I need to test that separately. All right. So that's the parser part of it. Let's see. These tests should all pass. Okay, let's commit that. Um, Slow going to GitHub this morning for some reason. Okay. That's. Well, we haven't interpreted it. Now, this is where it's going to get tricky. And I think maybe we have some preparatory work to do because right now the init the interpreter takes this is what I was talking about. The interpreter takes the whole parse of the whole program. And yet that's not really how our program is represented. So let's go back and I'm not sure about this thing either. Okay, so we have our REPL and it's going to execute one of our commands like line numbers. This is all the editing stuff. Okay, but it maintains a program. Let's see here. Let's just go into that. All right, this thing at its heart is int string, and I think maybe this program is what we need to interpret with. And so I want to make this the data structure that it has, because I'm going to feed in an int and get a line number. GOTO is going to, if you say GOTO 10, it's going to feed in 10 and get the line number for line 10 and then execute from there. Okay, so now how we're going to test this, I don't know. We can test the error case, but without an if, all we're going to do is write infinite loops. But at any rate, I think our interpreter should not be taking a giant string. It should be taking a program in this structure sense. Now, the fact is, all our tests use string because that's all we had. Interpreter tests. All right. So it passed in. Well, where's interpreter? Basically, it passes in the parse. Okay. And then that's self.parse. Let's see. I'm going to try and make it support program and parse. So let's move this into the interpreter. Move that there. Okay. Let's run our tests. We're going to do some stepwise. And I'm trying to be more systematic about renaming and that because I've screwed up my stuff too many times lately. Move program to interpreter group. And I would call that a refactor. Very good. Okay, now I could get it back. Let's see. Interpreter. I think I'm not going to need my test for a few minutes here. Okay. So interpret takes a parse. Run is the normal entry point. Okay, so let's give it a program as an option. Okay. Program of type program. Okay. If you get this program, I got subscript, I got list. Okay, well, that's not bad. Trying to figure out the best way to get it in there without, I mean, first I'm going to make it turn into a parse. Okay, if I do program dot list dot separate joined new line. Okay, at this point I have my program in. The result of that is a string. Make sure I'm getting my types right. Okay, so I've turned it back into a giant string. Now, what does everybody else do? Well, they have to call the parser. Okay, so let's call. Well, I'm gonna want to test after all. Okay, so parse program. Let's find our REPL again. Run interpreter equals BASI program. Oh yeah, we use BASI. Do I have it in here? Yes. Okay, give it a program. He does that. And this is clearly doing what we're talking about. I mean, I could do this. I'm not sure I want to. This is temporary, but it's like scaffolding to get us together. So let parser equal, and we'll make this program too. And then parse equal parser dot parse. Right? That's what BASI did. Interpreter with parser dot parse. Okay. Return from initialize. Okay. Nobody's calling this, so everything should still work. I don't necessarily like that the interpreter knows the parser, but we'll get there. Okay. So this is I don't know if you call it a refactor, but add an alternative constructor. Okay. Now, what I want to do is shift that anybody who ends in a parser, I would like to find everybody using this constructor and switch them to this constructor. Okay, so let's find usages here. I don't know if that's usages exactly, but I don't care about the inits. I care more about interpreter. Well, we know mostly it's tests. Interpreter tests. Okay. So here's one, parse.program, interpreter subparse. Okay. Yeah, I would like to Yeah, I guess if I get everybody passing in a program in the program object. Okay, so let's what can I do here? Well, is this maybe these tests, it's like I'm driving them back towards being line tests because I'm doing the parsing in there. I mean, the test, it'll read nicer. It's going to be something like let program equal program dot make I think if I did that and then I interpret with program, but then I'm testing. Boy, so the advantage of what I did here was I'm decoupling the parser from the interpreter, and I can say, here's a parse that came in. Do you work with it? Okay. Interpreter parse and then run. Maybe I provide a different run method. I mean, if I let you run with a parse, what would that do? Okay. Let's try that. Throws. So I'm still, it's kind of an internal thing. Run parse of type parse. Oh, well, that sort of means I should be down here to interpret. Okay, let's try it. Okay, so this is the function. I don't know. We'll see. Maybe I should just be calling interpret. I think that's the case. Okay, so I'm not going to say run the whole program. I'm just going to say interpret one line, I think. Okay, so interpreter.run. Well, let's do interpreter.interpret, and we have to pass in the parse. And a starting string. Okay. Maybe there's no value in even creating this. Okay, what if I do that? Interpreter equals interpreter program, output equals that. This test, I think, should pass. Okay. It may be wrong to hand in the program like this, but maybe the interpreter does need the parser. Maybe that's just part of what it should be doing. Okay, so I'm gonna. The thing is, I'm lying a little bit. I'm saying, start with an empty program and then interpret this parse, and what do you get? That's a little bit funny. Okay, but let's go with it. And I think I'm probably using the same line in each of these. And this is going in a level. Let's just do program. Okay, I believe I've done a refactoring. All right. I think this is all. Let's make sure. All right, so that means I don't think anybody's calling this anymore. Missed one. Okay, Basie. Oh, well. Basie has a program, so let's just give it program. We don't need this stuff. Is that correct? Okay, and this can go. Run them one more. Okay, so remove interpreter init that takes parse. Okay, and my to-do doesn't really reflect what we're up to, does it? We're still in GOTO, but reality, what we're doing is make interpreter work one line at a time. I think that's a more accurate version of what we're doing. Okay. Now, the parse interpret. Okay. I almost want to like step, right? That does one line of execution. Okay, and I'm still holding parse because I just built this giant parse. Let's okay. We're due for a break. Let's take a break. We'll come back and see how we want to. Somehow I want to hold the program. So let's take the break. Then we'll come back, make it hold the program, and switch it over to one line at a time. I think with a run or step that takes one line and does that line, and then maybe we can check something and see how we're doing. All right. So again, 3 minutes or so. Hi, welcome back. All right. Oh, there we go. Lag threw me off. All right. So I don't want to hold parse anymore. Who uses parse? Well, interpret uses it at this level. This passes it in. So I want to hold program. Let program of type program. Okay, and self dot program equals program. Okay, that'll save that. Shouldn't be affecting change. Okay, so well, that'll run. It tells it does it in like 1/6 of a second, and it's sitting here for seconds and seconds. There we go. Okay, yeah, 0.07 seconds. Okay, now the only time I need parse is when I'm down here and run. Let's see who calls this. Selected symbol. Maybe that's the one I want. Basic calls it. Okay. Interpreter calls it, of course, and some tests. Where's that test? Well, that calls interpret. It doesn't call run. How weird. Okay, interpreter equals interpreter program. Yes. Okay. I think Basie is the only one. Okay, maybe Basie's the interpreter at this point. Okay. So what I want to do. Okay, you gave it a program, and somewhere we need to figure out the starting line number, right? I think maybe that's what run wants. Okay, so let's see. I want to set this aside. Okay. I mean, the question I have is, hey, program, what's your starting line number, right? And it doesn't tell me that. I can get it because list gives it to me and all that, but I think I should be able to ask the program, what's your starting line number? Now, if I had that for run, would that help? Well, let's pass it in. There's no harm in Although I don't need it because I've got the program myself. Okay. Yeah, let's go make the program give us this useful bit of information. Okay. Um, it all right. Test program knows its first line number. Okay. Um, well, we can just put something in there. And then assert equal. 25 should be program dot first line number start. Um, first line number. Okay. Doesn't exist. Let's go to program. Um, returns int is a func. Okay. And make sure that fails. Okay. Should tell us. Oh, there we go. 25 is not equal to -1. Good. Okay. Now, um, this is all in this program structure. So let's do program dot, and then I think I can ask for the min somewhere. Well, I can certainly ask for the min. And get the key out. Yeah. Program dot min by. Oh, what was the quick help? Well, dot min by. We have to tell, given a key and a key. Yeah, that's okay. It's gonna be like the one above. $0 dot key less than $1 dot key. Okay, which tells me my test really should be more sophisticated. Let's add a line 40 as well.
Hey, Dad.
Excuse me. All right, sorry about that. Okay, so I want to make sure there's 2 lines in there just so something's doing some work. Okay, that gives me the value, and key is the type of the end result, so that gives me the int. All right, so let's see if this works. Believe I've done it right. Oh, true. Okay, min does not necessarily have a value. Okay, I think can I do this? Min question mark dot key. I think there's still an error. Yeah, it must be unwrapped to a value. Let's do that. Okay. We'll have to check the other case too, though. All right. And the other case is what happens if there's no line number yet. Empty program. Says first line number is 0. This is 0. Program is empty. Okay. And we'll run these tests. Okay, yeah, and now we pay the price there because that might be empty. All right, so let's return key. Let line number equal this. Line number line number is an optional, right? Optional element. Okay, so if it's there, I think I can say this or 0. Yeah, it's kind of one of those things. If you want to have, get something done, you've got to work on. Always have a good second project. All right, threading issue. Ooh, those are always tricky. Okay, so I think everything passed. Yep. Okay. All right. So you got your line number, return 0. That's fine.
I can go base over here. I don't want you to. No, really.
No,
No, we're moving it anyway.
Okay.
I'm moving it into the other room.
Okay.
I thought I would sit in the comfy chair. Yeah, there's
I think your daughter needs some help with getting lunch for her son. Is what I heard.
no. I didn't get a text.
The boss man said, the pretend boss over there, he said it had to wait till 11:30.
Oh, possibly.
Yeah.
Okay. All right. So now we can get that line number. So let's go back to interpreter. And okay. So run should take the first. Let line number equal program dot first line number. Okay. Now interpret, and this is return. Okay, interpret. We got the line number. Maybe I think maybe that's part of our state, our interpreter state. We got the program. Let line number. Well, let's just start with 0. Okay, so there is a line number. When you say run, let's capture that line number. Well, maybe we can do that up here. Let's do that here. Line numbers type int. Okay. So so far, this is all of our state of our program, right? We don't keep track of anything that's printed. So all we need to know now is the line number. Okay, this will grow a little. We'll need the variables and I don't know, maybe something else, some stacks. Okay. All right. So the line number is there. When you run, I think what we need to do. Oops, sorry. Um, hmm. Well, maybe this is where interpret parse as the program. Where's lines? Oh, the program knows the lines. Okay. All right. So this is this thing of moving it over to working off the line number. Let's I want to do it like this step thing I was thinking of, which is run one line. Okay. And what we need to do this concentration's a little messed up here. All right. So we're going to take the first line number. We somehow want to do a run. I don't know if we want to do a run line number. Well, I think what I want to say is let parse equal program subline number. Okay, and sorry, let line equal, and then I want to say let parser equal parser of lexer of line. Dot parse. Okay. No, what's mutable variable parser was never used. Sorry, this should be parse then. Okay. Dot parse parens. Okay. So if you run the program, let's see. You're going to look up the current line number. This is a var. You're going to look up the current line number. You're going to parse it and get a parse tree and pass that into interpret. But this is going to break a bunch of tests. Let's confirm that. Anybody who calls run right now, how is that correct? Oh, these interpreter tests. Let's see them. I don't think anybody, do they call run? Run. Right. We don't call run in here for our tests, really. We call interpret. Okay. Well, this, I think, is what we want to happen. Okay, so if you call run, we look up the current line. Let's hold the parser too, but yeah. So we dig up the current line and interpret it. Now GOTO is going to change the line number for sure, but nobody's looping, right? So this almost is run one line. Okay. All right. So I think I maybe want to stop here. Let's see. The tests pass, but I think we need to. Maybe we should define the next test. This is almost done. Maybe I can finish this. Do I need parse? I don't think I do. I don't think I ever look at parse at this point. Okay, who's going to complain? The top should complain. Return from initializer. Okay, because we don't need parse anymore. All right, let's run tests. Okay, let's delete this dead code. Okay, this is the consequence. We got rid of the global parse of the whole program. Now, I think, okay. One thing we'll have to do is delete parse.program if we work one line at a time. Okay. And test pass. All right. Okay. Let's stop there. We'll pick up tomorrow. Finish making one line at a time, and then the GOTO. Delete parse.program. Yeah. Okay, that'll be good. All right. Well, thanks for joining me today. I hope I can catch up in the future. Tomorrow is 9 to 11:30 Central Time, 10 to 12:30 Eastern, and 3 to 5:30 UTC. And thanks for joining today, and catch you later. Bye-bye.